Spotfire Essentials. In this class, I will be covering the TIBCO Spotfire development area from Spotfire introduction till information designer. Okay, I will try to go through different concepts of different analysis, visualization properties, document properties, formatting, filtering schemes, bookmarks, functions and expressions, calculated column, and few advanced visualizations like tree map, heat map, box plots, KPI chart, and waterfall chart as well. And then I will touch up a little bit on text area controls, how to use text area up to its full potential, and information designer with the introduction of what exactly it is, how we pull data in a more sophisticated way from database to the dashboard. Okay, let's start. To give a brief introduction about Spotfire, what exactly Spotfire is, it's a analytics platform which helps to make discoveries in data through immersive visual exploration and advanced analytics applications with the help of predictive analytics, geolocation analytics, and streaming at the scale of data at rest and data in motion. We will try to understand what exact these terms mean. Okay, analytics platform means Spotfire rather than being a tool or technology. It's a whole platform. It takes care of data from start till the report or the analysis application itself. So it helps in all the stages of data analytics, from retrieving data, transforming data, utilizing it to create sense out of it, and pull information out of that particular data. That's why we call it an analytics platform rather than a tool or BI tool or technology. There are tools in the market. For example, Tableau is a reporting tool which is used for visualizing the data. So this is not a visualization technology. It is analytics platform. Visualization technologies means the primary focus stays on visualizing the data only. They do not take care of data transformations, pulling, and pipelines, etc. Spotfire does all these things. Okay. Other thing, it helps to make discoveries in data. It helps to explore the data through immersive visual exploration. We see data here visually rather than just the raw data itself. And benefit of visual exploration is human brain is capable of interpreting graphics and visuals better as compared to the numbers, because numbers we need to learn. Our brain need to process it, but graphics and objects comes easily and they are perceived and processed more fast as compared to the numbers directly. So visual exploration helps in exploring the data and make discoveries over there with the help of advanced analytics applications. Advanced analytics applications means just visualizing data is not enough. Making proper sense of the data is also required. So Spotfire take help of different analytical approaches like aggregations, then transforming data, and then slicing and dicing it, focusing on a specific data set, etc., for creating a visual experience, and helps in making discoveries of data. And it take helps of different modern technologies like R scripting, Python scripting, Python scripts, MATLAB, and different kind of data processing approaches. Okay. Also, it helps with predictive analytics, geolocation analytics, and streaming. So what exactly they are? So if we talk about different nature of analytics, we have data exploration, means we simply look into the data and try to understand. Then second is called descriptive analytics. We try to describe what happened in the past. That's called descriptive analytics. We simply are willing to understand what happened in past. So just data exploration means we are trying to show the data as is without any changes. That's called this. That's called data exploration. Second thing is called descriptive analytics. Descriptive analytics means with the help of different tools and techniques, we describe what happened, how the data is changing, how it is getting modified over the time, what are the factors which are affecting the current behavior of the data. That's called descriptive analytics. And then comes the predictive analytics. Predictive analytics means it take help of past data and try to predict what is going to happen in future if we keep moving like this, or if we change a small variable, then what will be the impact on the overall business or overall numbers. That's called predictive analytics. Spotfire facilitates up to predictive analytics. There is one more type of analytics exist that comes into the data science domain, and Spotfire is slowly evolving from predictive to prescriptive analytics in a way. Prescriptive means based on the data available and the predictions, it recommends the business or to the end users that what we should do for profit maximization or loss minimization, or how to help in the decisions what people are taking. That is called prescriptive analytics. That enters into the data science domain rather than being in the data analytics domain. So Spotfire somewhere lies between predictive and prescriptive. It's not purely till prescriptive analytics so far, but it is far ahead from predictive analytics. And other type of analytics it has is geolocation analytics. Here, Spotfire take help of geographical coordinates, calculations, and the data related to different location and geographies for analyzing it in context of the actual data itself. Okay, so geography put a context of location to the actual data and effect of that particular geography. For example, the demand and supply may look very weird across the business. Okay, but if we try to understand in context of geography, for example, people in northern region, they look more for cold drinks and ice creams during March, and that particular trend doesn't much seems to be steeped in southern part of India. Like Bangalore have very nice weather as compared to the northern part of India. So a person in Delhi will take ice creams and soft drinks almost daily due to the heat, due to the high temperature. But a person in Bangalore, they will take these beverages and the snacks throughout the year evenly, because they are not observing that much fluctuation in temperature at all. So location also have impact on demand and supply. So geolocation analytics enables the end users to understand the effect of geography on the data and the numbers as well. That's called geolocation analytics. Third part of this thing, it's called streaming analytics. So whatever analysis traditionally we used to perform on the static data. But nowadays, data is being generated every second and even every microsecond, and the extent of data is ever increasing. Streaming analytics is an approach where we use any kind of analysis application as a container, and data keep flowing into that container, and those aggregations or formulas or kind of algorithms what we have designed to run, they are running on top of real-time data. That's called streaming analysis. And last statement, at the scale of analysis of data at rest. Data at rest means data which is static in nature, it is not changing that much frequently. And the data in motion means it's constantly being updated. That's called data in motion. So that's a brief introduction about what the Spotfire is. Okay. Moving forward, how Spotfire can access data. So in Spotfire, we have different type of loading mechanism. We can load data through import dialog and we can create data tables out of it. So what exactly data tables? In Spotfire, whatever data we see that comes through a data table, which is a collection of columns organized and placed logically in a context. Data table have three major components. One is columns. It's a group of columns, first of all. Second thing, it is an organized group of columns. Okay. And third, it have a context, like what this particular data table is doing. There will be a purpose or a context associated with that. And when we load data, we get options to use linked or embedded data. Linked data means we are directly loading data from the source every single time we open the analysis or we refresh the analysis. That's called a linked data. So where in the case of linked data table, we are pulling data every single time when we are refreshing the analysis or opening the analysis. The embedded data table is opposite to the linked. It loads data once and keeps a copy within a Spotfire environment. Okay, that's called embedded data. It will not be refreshed automatically until or unless a end user or a developer explicitly request for a refresh. That's called embedded data table. And what exactly we are calling in the end data table is, it's a cached collection of columns. Means we are pulling data, pulling the columns as a collection and caching it into the server. Stored in memory. In memory means it is getting stored in the RAM of the machine running the analysis. To be used in Spotfire to facilitate data. Okay. When we call something to be using data from a source, we are going to create a data table with the help of data available to us. Okay. So before moving to what type of analysis we have, let's have a brief interaction with how to load data. Okay. For that purpose, I'm opening up Spotfire. So when we have to talk about the import dialog. So let's say, first of all, I'm going to use a data set which is static in nature. Okay, let's say I'm going to use a flat. So basically, Spotfire can load data from a variety of the sources that may be flat files or a database table or a web API or REST API or any kind of service or connector which is being used by Spotfire. Okay, so when we open up a data, either we are supposed to browse a local file which is available in our machine, or we can connect to a specific connector. For example, Google Analytics or Databricks or IBM Netza means different kind of data sets like MySQL. OData means open data format. Oracle or Oracle SQL, PostgreSQL SQL means lot of connectors are available basically. So these connectors help you to load data from a specific service or the database. For example, Aurora MySQL, PostgreSQL, these are the databases, but the Databricks is a service. Okay, Apache Spark service. Similarly, Google BigQuery and Google Analytics, these are services which gets connected with the Spotfire. That's the second way, like using connectors. So flat files connectors, and then there is the approach of information designer or information link. From to use that, you can simply go to this thing library and use some pre-built information links from there. Okay, one thing to notice here, in other cases you directly referring to the data source. In case of information link, the information link should always be created in advance before opening the analysis. And what information link is? Information link is a stored SQL query in a Spotfire library, which is associated with the information of the source database, table, credentials, and the query itself. Okay, so we are coming back to browse local file. So let's say I'm opening up a file, sample file that is India population 2019. This is an open data set available from Aadhaar database. Okay, and there we get this kind of dialog. This particular dialog is called import settings dialog. For every single file or file type or data source type, the import dialog will be separately prompted in front of us. In case of Excel, we get option to choose worksheet, which worksheet we are going to use. Okay, and here we have some crucial components of it. First thing, whatever columns available into the data set, they will be populated on top: name, country, state, and population. The column names, basically the first row of the data set is treated as column in general. Second thing, we get an option to use a data row or a name row or the type row. So basically the first row by default is being considered as a name row here. Okay, second row, we can have a data row or data type row or data row itself. Okay, for a moment I'm canceling it to demonstrate other types as well. So let's say I'm using a text document, household power consumption. Okay, I open it up. See this, these values are coming up here, and here the first row is considered as name row. If I will simply ignore it and refresh it, the data set itself will lose the names. But if we include it back as a name row and refresh it, it will start referring those as name rows. Here we get an option to choose a separator, either tab, comma, semicolon, or space or others. Okay, and then we simply get a preview of the data available. Here we get an option to change the data type. For example, here date is formatted as string. I can format it to date again and refresh it. It will start populating. As this particular data is not in a proper format, it is being considered as an error. The value could not be passed as date. Okay, so that's the limitations of the flat file data sources. They're not that much dynamic in nature. Okay, now the third thing I want to show with the import dialog is using the hints for column type itself. If you have a preview of the data set here, you see this, the second row, I have used some hints like giving the type of respective columns, integer, strings. I have explicitly mentioned this is a date. Okay, so date and ship and respectively, I reached till here in postal code, somewhere it is there, postal code, and it looks like an integer, but I have masked it to use as a string. So this kind of hints can be picked by Spotfire very easily by using a entity called uh, data type row. And you can see here, it is referring to the worksheet, and types are already associated due to that particular row here as a hint. Okay, when we open it up, it starts loading data from the source. This particular dialog is called add and data to analysis dialog. Here it gives flexibility to specify what will be the name of data table. I'm setting it as orders data table. Clicking it OK will simply pull the data to the dashboard. Other thing, we have option to transform the data. We click here, we can perform certain kind of transformations over there. Now they include calculating and replacing columns, calculating new columns, changing column names, data type, data functions, different kind of things we can perform here. So I'm not going to cover right now because it will be too much for introduction to data tables. But yes, they are available here. And when we click OK, the data simply flows to the dashboard. To see that particular data, either open up the data in analysis dialog. They will give a brief about the values, and you simply click on this. Okay, you will get the overview of it, or you simply go ahead and click on visualizations panel. It is not responding right now. Just a moment. Go to the visualizations dialog and use a basic visualization that is called table. Okay. Table gives the data into the raw format, corresponding to the filters applied. So I am simply opening it up, inserting a table here, and we can see the data here. Okay. To understand the column types and all and the unique values into it, open up the filter panel. You can get the overview of all the columns and what exactly minimum and maximum values, what are the unique values for present into the categorical columns, and so on. Okay. What are the type of analysis? As I discussed, based on data load, there are two type of analysis that is called linked data set and embedded data set. Okay, linked means we are directly loading from the backend, and whenever the analysis refreshes, we are opening it the data set again and fetching the data, the fresh data from there. Okay, in a Spotfire context, this looks like this. We go to the data canvas, we select the data table here, and we look for this icon. This small icon have a state new data when possible. So always new data and new data when possible is a linked approach. It means that when analysis will open, this data table will pull fresh data from the backend and place it into the analysis data table. Okay, this is the called linked approach. But if I change it into stored data, even if backend changes or doesn't changes, it doesn't matter. It will simply load the data stored at this stage only. It will not refer to the new data set. This approach is called embedded approach. Okay. There is third approach which is called hybrid approach. Hybrid approach means if there are multiple data tables into the analysis, some of them may be linked, some of them may be embedded. Or there is another approach, data table half part is coming from embedded data set and some part of it you are using some kind of insert operation from a linked data table also to have a hybrid structure that's called hybrid data type of analysis. Okay. And fourth type is script based. Script based I will be covering when I will cover the Python data functions and Iron Python part, where we use some kind of code to populate data or fetch data from different places and place it into the Spotfire. That's called script based analysis. Okay. So based on data load, we have these very type of analysis. There are two more type of data analysis within linked category itself. One is called on demand. On demand means the data is going to be loaded in analysis only when user specifies the filters for that particular data. That's called on demand. And there is another type, it is called in database. The data tables will be linked to the database in real time, and Spotfire will not pull the data, but it will direct database to give the end result for different analysis performed at the Spotfire end, and database will be in real time interaction with the analysis itself. Okay. Now, when we talk about based on purpose, dashboard is some kind of analysis which will be one page, usually non-interactive in nature, but it will show the real-time data or near real-time data. That's called dashboard. Report will be similar to the dashboard, but there will be more than one pages available to show the key values for the end user reference. Third kind of the analysis is analysis or application itself. This is the most common, and I use this term itself repeatedly. The analysis. Analysis means it is loading data and allowing end user to interact with the application itself to filter down, slice and dice, interact with, change certain things over there, and having some control at the end user side. That's called analysis or application. And fourth type of analysis is hosted solutions. Means Spotfire is repurposed for something different than the regular data analytics itself. Is called hosted solution. For example, it is being used as a data entry tool. It is possible in Spotfire It is not a native data analytics, but there is a possibility to use it via different scripts. This is so in Spotfire, we have 15 native visualization and one text area. Okay. And we are going to talk about visualizations, basic visualizations first. So in general word, what does the word visualization means? Okay. So the first thing that comes to our mind when we talk about word visualization is visual. It means that it should be something which we can see. And visualization means the representation of data as a visual element. That is called visualization. And in Spotfire, wherever we are showcasing data as a visual element, that is a visualization. That's the safest term. Okay. There are other words people use sometimes, like chart, plot, or graph. Okay. So although there is no harm in using those words, but they have specific meanings. Graph is something where the x-y coordinates do have a meaning and the area is significant um, thing there. Okay. So basically, where exactly it is plotted and where exactly we have drawn the things, that is a graph paper. Where what can be drawn with the help of a graph paper is called graph. Basically, bar chart or line chart is called line graph or bar graph. Means that there we use the help of graph paper to plot in general. Okay, that's where exactly they call graph. There's something called plot. Plot means something which can be drawn. That's a safer term. Okay, where the xy coordinates have significance. A scatter plot is a plot. Table is a plot where row and IDs have significance. The place defined for the data points. That is called plot. Chart is something where we represent area on a chart paper or a paper to represent data. That is called chart. That's why we call pie as a pie chart. In case we do not want to get confused, in general we use the term visualization. Visualization means something that helps to visualize data. That's the safest term. Among all the things as in the visualization area, from the authoring bar, the text area is the only component which is not a visualization because natively it is not having any kind of data or data table posted there. Okay, it can be used as a visualization when we use actual data, but till the moment the actual data is flowing in, we cannot call it as a visualization. That will be simple text area itself. Okay, now coming to the basic visualization and the simplest one of all, that's called table plot. Table plot is a utility to display raw data rows, and it displays specific columns of end user interest. Okay, in analytics world, tables are the most reliable visualizations. Okay, reason is as they are showing raw data, the data is unaltered in their original form, first of all. Second thing, they can be exported for further analysis with the help of alternative tools like Excel or any kind of other technology we can use. Okay, by pivoting or further analysis on the top of data, or simply by referring the values by with the pen and paper. That's called raw data. So to represent raw data, we use table plot. It has few features and few limitations. And basically, those limitations are also featured as features only. So main intention of table plot is displaying the raw data. and we can limit down the rows of interest. For example, there may be 20 plus columns, but we are simply interested in few of them. Let's say order ID, order date, order priority, sales, discounts, shipping mode, and profit. We don't want to show the cost, the simple thing like the customer name, region, sales, discounts, or etc. Means other things we don't want to show, we can simply hide. That's the feature of table plot. We can sort the whole data set based on one or more specific columns in increasing or decreasing order. One thing we cannot do is we cannot aggregate data. We cannot show any calculated calculations in front of this particular visualization. So basically, that's why it is having that much importance. As it cannot be altered, customers trust it most. Like they know that table plot cannot be altered, so it shows the original data. There is no uh, modifications have been provided, have been performed by the developer itself. So it's most reliable. Okay, just have a brief interaction with table visualization. Okay, in front of you there is a table visualization. For example, I'm picking up one simple visualization. Go to authoring bar, select the visualization types, and here I select table. Okay, one thing you can remember here, like in case you are in hurry, you want to simply create a visualization simply by keyboard shortcuts. They're also available here. Okay, for example, to insert table plot, you simply hold Control key and press 1, and that will be done. And to know what shortcut keys are associated, simply click on Visualization type, hover over there, but don't click. You see that there will be a shortcut name written. Add a table, bracket, Control plus 1. Similarly, for pie chart, Control plus 7. Heat map, Control, Shift, and 3. Usually, that's 3. If you have to simply create multiple visualization, what I do, I simply hold Control key and type 2, 3, 4, 5, 6, 7, 8, 9, and 0. And there will be some visualizations created by default. Okay, that's the fastest way of creating some dummy visualizations over there. Okay, here come back to the table plot. You can see by default all the columns have been represented here. They may not have significance for our analysis. For example, row ID doesn't add any value. Okay, and customer name and customer segment we don't want to show in our dashboard because it's a kind of um, confidential information. Okay, so we go to the property. What options we get? We can remove all the values from the viewport and select specific ones. For example, order ID doesn't add any value, but order date, let's say order ID itself also there. Okay, then shipping date, let's say we have it here. Shipping mode, we use that. Customer ID and customer name, we are hiding it. Customer segment, country, we add here. City, state, we add here. As country is same for everyone, it doesn't make any sense removing that. Then we go for region, then category, subcategory, product name, we are adding them. And then amount of sales and profit. We want this much only, we don't want other things. We simply add them and they are populated in a table plot. What other things we can do with the table plot? There are general properties. Basically, we can change title of any visualization. So we get title bar here. We can edit it to directly have the heading over there. We can add description. Okay. Data for orders table. We can show or hide the titles. So let's say I'm showing just the title, not description. In colors, we can give specific colors to the values over there. Okay, so let's select one specific place where we want to add colors. For example, I want to add colors based on the category. Okay, right now coloring mode is set to fixed. So we got four different coloring modes, but here for the categorical value, just two of them are available: unique values and fixed. Unique value means one color for one value that will be assigned here. And basically, we can change it. Furniture, let's say I'm using blue. Office supplies are in light orange, and technology in darker blue. We are going to set that. Okay, we got an option to, rather than using the background color, we can use a text color as well. Okay, and there it will have the different effects applied on the values. Okay, other thing what we can do, either we can use sorting by this particular approach by selecting one specific column. Let's say I'm sorting by order date. We can arrange it as sort ascending or descending order. As soon as you sort by one field, you can sort by other field following to that one. This particular becomes enabled. Right now, third one is disabled. As soon as I will set something else here, okay, that will also be enabled. So sort order will be first sort by the order date, then by shipping date. If I select that, means the second one, and then by the third criteria. Okay, the, let's say, city. Okay, and we have an option to change the order to ascending or descending. If you don't want to do that, from the properties dialog, we can simply click on a specific column. Let's say I am doing it by profit. And if I just want to sort by profit in descending order, we select this one. Okay. And then if we want to sort it by some other column as well, let's say if I select this one, the whole data will be sorted by just one column. But as soon as I click on this one, okay, increasing order, but plus sign associated, means that add this sorting to then by criteria. Okay, and that will be simply done. And here we can add multiple columns for shopping. That's the key approach here. So the things available in with the table visualization is we can change colors, select the specific columns, and sort the data. What we cannot do is we cannot aggregate data in case of table plot. Okay, now coming to the next visualization. Okay, so table plot, when to use it? Simple thing, we are going to use it for showing the raw data, and almost in every analysis requirement in a form or other, people look for the raw data. So we usually create a tab to place the raw data for end users reference and allow them to download. So it is kind of a visualization that is natively made available by developers for the end users. Okay, regardless of they ask or not, by default we provide it because we know that in some point or other they will be asking for that. Okay, so it is applicable everywhere. So we can give that particular option. We prefer to place this raw data in a page where just this visualization is available, or just similar visualizations are available. Call the tab itself as a raw data or data extract so that end users can refer it. Usually people rarely refer it if they are true BI users, but in case of certain issues they want to analyze it externally, they will refer it. Okay, next type, this is called summary table visualization. Concept is very simple. We got different aggregations available on top of data, and there are different columns. We want to see that aggregations, list of aggregations for all the data available. Summary table is used. Practically, there are very rare situations where we use summary table because each column have there is specific requirement for aggregation, and all the aggregations are not relevant for all the columns. So there we either left with two options. First, have separate summary tables for the separate group of data, or regardless of not the particular aggregation is available, if we show everything and let end users select what they want to see. Okay, summary tables are simple visualizations. They're simply used to display aggregated data, and it's basic introduction to aggregation itself. Okay, doesn't have any complex thing. They simply summary table allows to select two things: aggregation and the columns, but you cannot add coloring or marking over here. Okay, purpose is very simple, just show the aggregated data. There are a lot of limitations. You have to purely depend on the filtering itself to show a specific value, and end users should have the knowledge of this one. So that's why these are rarely used. Still, if you want to create it, it is very simple. Okay, I'm going to use this tabular visualizations tab itself. A sample is shown here. We simply have some aggregated measures over here and some columns. So as we know that sum of profit does make sense. Okay, average also does make sense. Minimum and maximum profit is valuable. Median is definitely valuable. Count, if we could have shown just for one of it, in sales, quantity, discount, or profit, then also it would have significant, and it would have been solving our purpose. But showing it four times doesn't make it add any value. Either we exclude it from here, but that will lose the purpose. But if you show it, it will show for four times. Also, this particular information, sum of discount, doesn't add any value at all, because discount is specific to a specific order of commodity. Minimum and maximum does make sense, that what is the range we provide. Median also have some sense, and average also makes sense, that on average how much discount we are providing, what is the median of those values. But some of the discounts doesn't add any value at all. But still, if you use a summary table, that will be shown. Either you exclude whole thing, or you have to show the whole thing. That's the limitation of this particular type of visualization summary table. You cannot mark data or select something from here, and you cannot change colors as well. This is all what you can do. How to use it? Simply go here and select summary table, right click, go to properties, select columns of your interest. Row ID doesn't make any sense. Sales, quantity, discount, and profit. That's all. Means we selected the particular columns. Okay, and then we go to the statistical measure we want to show. Sum, average, mean, max, median. Standard deviation doesn't make sense. We take it out. Let's say count. Count will be having some value. We use that. And that's all you can do with a summary table. You cannot do much on this one. Okay, so that's the whole thing with summary table. They are simply used for showcasing the averages, means the aggregated measures. They respond to filtering, of course, like any other visualization. For example, if I filter down to a specific customer ID, the values for that particular customer IDs will be filtered down. But you cannot use markings or any kind of coloring, highlighting, etc. That's not allowed into the summary table visualization. Moving to the next, when we talked about aggregations, we felt a need of aggregation flexible enough for us. And cross tables are basically most used numerical representations in our world. Means even the Excel users call it as a pivot chart, pivot of the data, that are basically representation of cross table itself. This is the most flexible visualization in terms of using numerical data and adding aggregations over there. It's a kind of just the simplest introduction to the aggregated data. It works like pivot table. You can add marking, coloring, and you can add column subtotals, row subtotals, grand totals, etc. Here, the main purpose of this visualization is to provide aggregated details of the data at overall level and as a precise values. Okay, so cross table always give you precise values with the help of numbers aggregated at the scale of data table itself. Okay, this is a form of summary visual. Okay, summary visual means you want to see the overall summary of data itself as precise numbers. This will be very helpful. They are used for performing a specific type of analysis on numerical values. For example, we want to identify the value which is most significant. For example, product subcategory attracting maximum average profit. We can simply use the category, subcategory on an axis. On other axis, we can put different departments. On values, we put average uh, profit, and then we color by gradient of the profit itself. It will exactly highlight the value what we are looking for. Just see it. Okay. In cross table, we have this thing called row axis. Row axis means how to split the data in different rows. Okay, it's a categorical axis. Basically, it splits the data into the categories selected here. Basically, category and subcategory information on row axis. The data will be aggregated at the finest granularity. Finest granularity means this node subcategory is coming just previous to the actual data itself. So this node is called leaf node, and the one which comes at the topmost level is called the root node. So the data will be aggregated at the leaf node, and it will be segregated in a hierarchical structure, parent to child relationship. Similarly, on other axis, the vertical axis as well, the similar kind of thing can be used. Here it is used as a segment and a column names itself. And two values are used on the value axis here. So let's okay. So let's create a simple cross table. Okay. Let's say we want to perform the analysis of average profit. First of all, we will remove all the other values from here. Okay. We are simply looking for average profit. We select that one and select the aggregation. Okay. Now we want to see the split of these profits by specific categories and subcategories. We select category. The category level average information is shown here. If we add subcategory level information, the data will be splitted into this way. Right click and go to the subtotals. For all, you will get the subtotals appearing for the specific categories. If the two levels of data is used, so the subtotal for this parent level will be shown at the bottom of this one as aggregation subtotal. And if there are more than that, basically let's say I'm taking the product name as well, so the data are at sub category level will be shown here. Okay, and when this particular subcategory will end, below in the same line itself, the parent category subtotal will be shown here as an aggregated measure. Okay, for simplicity and removing the one level of hierarchy. You want to see the data splitted, same data means that split should be same. Either you can use the level of customer segment here itself, and it looks like a tall table. But rather than using a tall table, you want to use a wide table. Just drop it to the columns axis here. So this whole data set will be splitted into the leaf nodes of both the axis. Basically, leaf node here is only one node. This is a leaf node of segment and combination of category and subcategory. Okay. Now all the values are summarized here, but you want to find out the category which is most significant. For example, on you want to see the average profit, maximum average profit of which subcategory you are getting. Okay. Go to the colors. There are numeric values. So on all values, you simply apply a coloring mode called gradient. Okay. And here what you perform, the maximum should be shown into the dark blue and minimum into this one. So it shows clearly this one is having the maximum value 964.9. As these ones are not that much far from each other, 949 and 964, they're closely to a similar gradient here. We can use different kind of coloring mechanism over here. For example, this thing top n, and I'm going to show top one category, which is the maximum profit attracting category. That is a maximum average profit, that is copiers in home office segment. This is the benefit of using the coloring over here. You can apply is similarly the coloring to text or the values directly, or you can use this kind of min average max approach. So minimum value into the green, average at black, and the red ones in the max. As the dark theme, black is not that much visible, make it like green, white, and red, and you can see that particular data. It helps you to identify. So the key benefits of using cross table is you are able to aggregate data at axis as average profit, or let's say I'm taking it in comparison of the sales as well. You can use multiple aggregations on the values axis. You can split data in horizontal or vertical axis over here to split the things, and you will be able to have a brief summary of the whole data itself. It will respond to the filterings,